It's official. Stage 4 has begun. Stage 4 are all the finishes. It's all the things that we need to do to make this dome look beautiful. One of the first things that we're going to do is install these interior skins.
Welcome back to GeoJourney, episode 11. Amma One is starting to feel like a real home. Windowsills, interior panels, and a circular staircase, all making you go, wait, people are actually going to live here. This is now fully becoming a home. We're gonna head over to Neil and he's gonna give you an update.
So these guys are installing one of our interior skins. We use the Duracryl to temporarily hold these in place, and then the cap goes in. So when we release this cap to put in the next skin, it will hold the previous skin while we get it located, and then we secure it with the cap. These interior skin retainers, or caps, screw directly into the hubs, which retain the skins and hold them in place and secure them to the wall. The interior skins are similar to the exterior skins, except that they have less sand and air that we've entrained into the ceramic material. These skins have facets. They do a couple things. They're a beautiful design, and they also help take up some of the echoing that can happen inside of a dome. We are installing the interior skins as well as the interior windowsills. We have also installed the exterior doors. The windowsills are made in the factory, and then they're brought to the site. We bring them into the dome, and then we use a CAD program to define the precise location. So as you notice, we finally have the stairs in. These stairs came in 3 parts. First, we installed the inner stringer. Then we installed a couple of the treads down at the bottom and one at the top in the landing. So then we could marry the outer stringer to the inner stringer, and then we installed the rest of the treads.
Every single panel, sill, and step on that staircase was refined and tested before it ever got to site. And that's what Geoship is doing differently. The beating heart of this company is our engineers. I'm so excited to introduce you to a few of them.
So if you look at our team, you'll notice something kind of interesting. Most of the team comes from the automotive industry, where we are trained to build thousands of one thing and not one-off products. So within that training, you learn the process of engineering for large volume.
It's not a mistake. This company is full of engineers. You know, all of the best products that we use in our day-to-day lives, phones, laptops, cars, these are all built by engineers. When you look at the home through the lens of a product with a bunch of engineers, you're not looking at it like a thing that we build. You're looking at it like a machine or a system that we build, like a car. And when you do that, you then understand and consider how each component and each part interacts with each other.
Okay, so what does it actually mean to engineer something as a product? There's actually a shape engineers draw on the whiteboard for this. It's a V. We call it the V diagram. You work your way down one side, breaking the problem into smaller and smaller pieces. And you come back up the other, putting it all back together, and validating as you go. You don't move forward until you've checked all the boxes and passed the review. And then run the analysis, validate the design, and loop it back.
Early on in the process development, you can make cheap tools that are quick and easy but get you the right design. Once you get further into production, then the tools become more expensive because you need to build many off of that same tool. So if you find an issue within the V cycle with one build, you want to go back upstream, find the root cause of it, and fix it such that you don't have that same problem occur again and again.
Prototype testing is what it's all about. This one is the slice. It's 1/14 the size of Amma Founder Edition Dome. You can put your hands on it, see it, feel it. It allows us to find the things that aren't working and fix them. At Tesla, we built 100 Model 3s at a pilot facility called Cato, way before the main line ever turned on. The whole point is to find what's wrong while it's still cheap to fix. And that's where we are right now, building, touching, fixing, learning. So when the line turns on, it turns on.
The way houses are built today is they're one-off, built by craftsmen. Raw materials get delivered to the site and they cut things to fit. In automotive, you have parts show up to an assembly line, so there's no cutting, no measuring. We want to bring those kind of processes to home building. So you assemble on site rather than construct. Why this matters to the customer is that it'll improve the product quality while also reducing the cost.
Here's something you might not realize about how cars actually get made. We don't just design the car, we also design the manufacturing technology and production lines to build the car at the same time.
The factory teaches us how to make better homes. Every single home we make, we learn, and we build another one, and we get better every time because of the machine that we've built to help us build the home. It's the machine that builds the machine.
A quality product at a price you can afford doesn't happen on a dirt lot one at a time. This happens when you see the home as a product, engineered, validated, and manufactured.
Almost everything else in your life was engineered as a product. Designed, tested, refined, then built 1,000 times. Everything except the house you live in. There's a big difference between a house that passed inspection and a home that's been engineered. At Geoship, we've got the engineering to change the expectation of what home can be.